Hey everyone. Okay, Unit 8 test review. There's no calculator, no unit circle, so we're going to teach you how to find the answers without those things. These are the formulas. You could get those from your notes, or there's a PDF of the answer key to look at. Also, this was from the quiz, so you can, again, look at the PDF for these answers. Most importantly, that the sine of 0 is 0 and the cosine of 0 is 1, and that you know that. Again, from the quiz, can you name these graphs and do you know why each one is each graph? And I'm going to go over this. I'm going to see how far I get. We might have to do 2 videos, but first we're going to start off with these. So the parent function is always like the most basic function, which will be y equals sine theta, which you have memorized. So graph the parent function lightly in pencil. Okay, so we know sine of 0 is 0, sine of pi over 2 is 1, and then the pattern goes sine of pi is 0, negative 1, 0. And the pattern continues forwards and backwards. Ooh, I skipped one here. Okay, so hills and valleys, concave down, concave up, concave down, no zigzags, and nothing like that. Nothing like that. Okay, so there's my parent function. Yeah, it keeps going this way, and I didn't do it very lately, but it's okay. All right, now how is this transformed? Let's see what color I want. Blue. Okay, you ready? There's 3 things happening. There's a negative, the 2, and the plus 1. So do you know what they all mean? Okay, what is a negative in front? Remember, usually that was like an A. So because we have A is negative, then the sign it's going to be switched. All the positive points will be negative and all the negative points will be positive. So a lot of students like to think that we're going to start by going down. We're not going to do that one yet. Okay. What is 2? 2 is called the amplitude. And remember, it's always the absolute value because it's a height. Amplitude. I don't know if I'm spelling that right. I'm a little tired. And then what's the plus 1 on the end mean? Plus 1 is our vertical shift. So did it shift up or down? If it says plus 1, we go in the same direction. So it says plus 1. So we're going to go up 1. Okay, you ready? Here we go. So here's our sine curve, and we're going to move it up 1, and that becomes our new midline. You should say midline. Midline. So no longer are we on this x or theta axis. We've moved up 1. Okay. So sine of 0 is still 0, but it's 0 plus 1. So we're up here. This dot has been moved up to this one. Okay. Now we're not going to go in the up direction because we have a negative in front. So we're going to go in the down direction. And the pattern usually goes up to 1. 0, 1, 0, negative 1, the pattern now is going to go down 2 from the midline. So not to negative 2. It's not going to go here. The amplitude is 2, so we're going to go down 2 from the midline here. Back up to our midline. I was going to call it 0, but it's not 0. It's plus 1. And then from plus 1, we're going to go up 2 from 1. So 1 plus 2 is 3. Okay, you practice this on the range. Remember the range questions on Desmos? Do you see how my points are still on top of each other here and here from the parent function? We are not stretching or shrinking. So we're not changing the period. We're just doing the other things. So here's our new sine function, or the sine that was given to us. Let's see if I can continue this pattern. So we're going to go up 2, midline, down 2, midline, up to midline. How do I do that? I think about it as different pieces. So I go up like that, and then I go like that. And then I just connect them. If you don't, oh, it's a happy face. If you don't, you're going to find yourself doing this, which is wrong because it's supposed to be concave down like a frown, concave up like a cup, concave down. Okay, that's it. Did I do it right? Let's double check. I don't like how dark they are on top. I should do the parent function lighter. Okay, did we move it up 1? Yes. Did we go down? Yes. Are we going down 2 and up 2? Down 2, up 2. Yeah. Way to go. Okay. Should we say the range? Because we've been practicing that, right? The range is going to be from -1, inclusive, to +3. Okay, let's do another one. Now we're on cosine. So I'm going to do cosine in the parent function in pencil. So cosine starts at 1, then goes down to -1, 0, 1. That's the pattern. And remember what I said, I'm going to make it like this, concave down, concave up, concave down, try and do it lighter, concave down. Okay, that's our cosine function. Now what has changed? So we see that the amplitude equals 3, and the vertical shift, it's been shifted what? Down 2. So we're going to go down 2, and that creates our new what? What's that called? Our new midline. New midline. Midline. And then from the midline, usually we go up 1 or down 1, but now we have an amplitude of 3. So from the midline, not from the origin anymore, we're going to go up 3. 1, 2, 3. Okay, oh, we're at the same spot. And then here, this was on the midline, so we're going to put that point on the midline. So we went from 3 to the midline, and now we're going to go down 3. On the previous one, we had to switch. 1, 2, 3. I just thought it was silly. It's on the same point. Why did we switch on this one? How come the original was going up and we went down? Because of the negative. But this one's positive, so it's going to look like our positive cosine. Okay. Lights. What does this look like? Do not do a zigzag. All right. Needs to be a curve like this. A hill, concave down like a frown, concave up like a cup. A frown, and then up. See how I switch the way I think about it? Like I pick up my pencil. That's pretty good. Yeah. Cosine function moved down 2, stretched up and down 3. Let's do another one. Sine's kind of boring. Here we go. Sine -3, so y equals sine. In pencil, they didn't give enough room to draw the parent function. You know what? You just do your best. Do your best. Okay. That's our sine curve, and it feels like we have a lot more going on. I feel like I've done that before. Look, I skipped a point. So we go from 1 to 0 to -1. Sorry, I caught it. There we go. Okay, what's the transformation on this one? Amplitude is still 1. It's positive. It just went what? It moved down 3. So here we are. What's this line called again? I've only said it, I don't know, 5 times. It's called the midline. From the midline, amplitude is 1. It's a positive sign. So we're going to go up, down, like that. All right, so if you participated in the Desmos activity, this should be pretty easy. Some people, though, you wouldn't believe it, some people did not participate. Sad. So they're scrambling right now to learn this before the test. Remember in middle school, your teacher said, put arrows so that you show that the graph is still going? That's true. It doesn't end. We should kind of end our graphs with an arrow. Okay, last one. -2 cosine plus 1. So our parent function is cosine, which starts at the maximum, middle, minimum, middle, max, middle, min. What the heck is she saying? Here we go. Pop, 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 pop. You're going to see these wave functions in different science classes, maybe physics. We're talking about light or waves or currents or temperature. All right, vertical shift of +1, you agree? Amplitude of 2, but we have a negative. So do you see how cosine always starts at 1? But now it's going to start at -2. Oops, but not -2 here. It's going to be 2 down from the midline. So now we have a cosine that's been reflected over this midline. So we went -2. Now we're in the middle. Now we're going to go up 2, middle, down 2. And it kind of looks like a absolute value, but it's not an absolute value because we know we need to draw these concave down, concave up, concave down, like that. This goes to here. Really helps to draw the points. And then double check it. Okay, did I move it up 1? Yes. Did I reflect the cosine? Yes. And is my amplitude 2? So from the midline, did we go up 2 and down 2? Fantastic. So that's a little review of sine and cosine. I hope you can tell we made it a little bit easier. There's no period questions. There's no period, no stretches or shrunkens. And we stuck to just sine and cosine. So if you can get these basics, it's a really good start into trig. Okay. It says complete the rest of this page on lined paper. I'm going to do as much as we can, and then we'll have to make a second video on lined paper. Can we use graph paper? Yeah, it doesn't matter. It doesn't matter. I just meant like a separate sheet of paper. Okay, number 11. Tip number 1 is to change everything to sines and cosines. So I see a cosecant here. Cosecant, what's cosecant equal to? 1 over s goes with c goes with s goes with c goes with s, 1 over sine. And then secant is 1 over cosine. And our goal is to try and make one side look like the other side. And that's our numerator over cotangent. What's cotangent equal to? I always remember tangent is sine over cosine, so cotangent must be cosine over sine. And we're not going to touch the right side. The right-hand side, we're waiting. Okay, we're going to try and make this left side look like secant squared. Okay, how do you divide fractions? I mean, this is something we all need to know. How do we divide fractions? We multiply by the reciprocal. So we need to think of this 1 over sine times 1 over cosine as our numerator. And, let's multiply straight across, sorry. 1 times 1 is 1, you all agree? Sine times cosine is sine times cosine. So do you see how we wrote, it was 2 fractions with a multiply, we wrote it as 1 fraction? And now we're going to multiply by the reciprocal of this denominator. So if this is cosine over sine, we're going to multiply by sine over cosine, like that. All right, what happens next? Do we have a sine divided by sine? Sine divided by sine cancels to a 1. Careful with the word cancels. It doesn't cancel to 0, it cancels to a 1. And we have 1 over cosine times cosine. Cosine times cosine? It's cosine squared. What are we trying to make it equal? We're trying to make it equal secant. Is 1 over cosine squared secant squared? Yeah? Cool. Good job. We did it. We did a trig identity. I'm not sure if I have time to finish number 12. We'll see. We will see. You can tell that one was not as hard as some that we did in class. I'm not sure what to do, so I'm going to change to cosines and sines. This is already a sine, and tangent is sine over cosine. Look at that. The math gods have blessed us. What did the math gods bless us with? A common denominator. Okay. So do you guys see, sorry, this is 1 minus, what's sine times sine? Sine squared all over cosine. How come we can combine it like that? Because we have a common denominator of cosine. Okay. What is 1 minus sine squared? 1 minus sine squared, that should be memorized. You should know that that is cosine squared because of the Pythagorean identity. And now we have cosines. Why am I writing this every time? You don't have to write it every time. You just kind of have to write it the first time and the last time. So I apologize. Okay. I'm out of time, but we know that cosine squared plus sine squared equals 1. So cosine squared equals 1 minus sine squared. That's what I did here. 1 minus sine squared is